So the fertilizers contain three elements. You remember, again, core knowledge, N called NPK fertilizers, and the NPK stands for the three elements: nitrogen, phosphorus, and potassium. So any one of those three could be put in here. I'm just going to put nitrogen down as the answer to that particular question. Okay, we've got to complete the equation. Now, it tells us here that potassium nitrate is formed by this reaction. So if you've forgotten the formula for potassium nitrate, we can work it out over here. So potassium is in group 1, so it wants to form a +1 ion, and nitrate is NO3 minus. Here it's a little bit of a hint that NO3 is a minus because it's only got one hydrogen, hydrogen's plus next to it. Both want to make one bond, so cross those over. So potassium gets a number 1, so that's just K. Nitrate gets a number 1, so that's just NO3. Now we need to find this fourth chemical in this reaction, the second product in this reaction. This is an alkali and acid. So acid alkali makes a salt. This is neutralization, so we also get water. So water is going to be H2O, 1 mark for each of those two formulas. Name the type of reaction we've got here. Well, this symbol here means this reaction is reversible reaction. Give the formula for a molecule of ammonia. So ammonia is NH3. Let's imagine you've forgotten that formula. How could you work it out? Well, nitrogen is in the group that wants to make 3 bonds. Hydrogen wants to make 1 bond. You cross those two over. So nitrogen gets a number 1. I don't need to write it down. Hydrogen gets a number 3. So NH3 is the formula. Okay, next one. State the overall trend in the world production of ammonia. So if we look here, as we go on in terms of time, the amount of ammonia produced increases. So here we can say you say increases. Hydrogen can be obtained by hydrogen oxygen fuel cell. Give the product that is formed. The only product formed in that reaction is water. Okay, this next one is a 6 marker, so it's a longer answer, and you can see here they're asking you how to prepare a dry, pure sample of ammonium sulfate crystals. And it tells you that they have to do a titration, so we're going to talk about titration in a moment. And then we have to prepare the salt and make it pure and make it dry in order to do this. So there's a couple of different stages here. I'm going to deal with the titration first. Then we're going to deal with kind of how to make it pure and is within the titration a little bit, but we'll show that differently. And then to dry it is the final stage. Okay, so here's what we do. First of all, let's do the titration. So in the titration, we rinse the burette with sulfuric acid, and then we're going to use a filter funnel to add the acid to the burette. And at the start, you record the volume of the acid in the burette. We're then going to use a pipette with one of those safety fillers, and we're going to transfer 25 centimeters cubed of the ammonia solution to a conical flask. Once it's in the flask, we're going to add an indicator. I've picked phenolphthalein, and phenolphthalein in the ammonia will turn pink. I'm going to place a white tile under the conical flask, and that's allow us to help us to see the color change taking place during the reaction. We're then going to add the sulfuric acid to the ammonia solution, and we're going to swirl the conical flask as the acid is added. And near the end point, we will add the acid dropwise. So as soon as that pink color fades and becomes colorless, we'll stop adding the acid and record the end volume. At that point, we then can calculate how much acid has been added, and we would repeat the experiment until we obtained concordant results. That's two results within 0.1 of each other. Then, to get the pure sample, we'd repeat this experiment, but we do not put any indicator into the conical flask. We would add the exact amount of acid that we worked out from this experiment, and at the end of that, the solution that we formed contains ammonium sulfate and no indicator is present. So that's our pure salt formed, but now what we need to do is get the salt out of that particular solution. So, preparation of the salt. We'd heat it in an evaporating basin and we'd evaporate the water. And as the water starts to evaporate, the solution will become more concentrated in terms of the salt. As the salt starts to become visible, we'd leave it to crystallize. Let me put a second L in there. We leave it to crystallize, and we'd place we'd place on top of a filter. Point's going weird. Then we place on top of a filter paper, and we place another piece on top, and that would just help us to dry the salt by absorbing any moisture from it. Okay, I've worked out there are 20 bullet points there. So what they would do is count how many bullet points you've mentioned in your response, and this would then work out how many points you've got, and therefore how many marks you're going to be awarded for that particular question. So if, for example, you got over 17 of the bullet points, you get 6 marks for your response.